Hello, welcome to Unified Science Lab. Today we are going to solve example under a moving coil, and the question says a moving coil ammeter has a fixed shunt of 0.02 ohms with a coil current resistance of 1 kilo ohms and need potential difference of 0.5 volts across it for full scale deflection. And the question 1 says, to what total current does this correspond? And the number 2 says, calculate the value of shunt to give full wave deflection when the total current is 10 amps and 75 amps. So we are going into the formula, the solvings now, which is solution. And I would like to write out the parameters that is being given there. Given that. So according to the question, these are the parameters that is being given. I want to solve the first one now. To what total current does this correspond? To this where is it? The shunt resistance is being given to be 0.02, and the resistance is being given here to be the current resistance is being given here to be 1 kilo ohms, which is 1000 ohms, and the voltage is 0.5. Then doing the solvings, we have the formula Im is equals to V all over R, which is V is the voltage here is 0.5, and the current, which is R, is 1000. And doing the normal calculation, the Im is equals to 0.5 divided by 1000. That will give us 0.0005 amp. Remember, current, this is a unit for current. We are solving for the Im. So the question was, what total current does this correspond? So to have the total current, the formula to have the total current will be the I total is equals to I shunt plus I meter, is Im. That's it. So now we have solved for Im. We need to solve for Is, which the formula to solve the Is according to this Ohm's law. Ohm's law says voltage is equals to IR. V is equals to IR. So V, we know V to be 0.5. Do I need to write this again? Let me just write it well. I is R is V is 0.5, and I is here is not being given. We don't know I is equals to I is times R shunt resistance is being given to be 0.02. So make I is the subject of the formula. So then you have I is equals to 0.5 divided by 0.02. That will be 0.5 divided by 0.02 will be 25 amp. Now, since we have the Is and the Im, we now solve for the total current. The total current is I is equals to I is plus Im. I here will be equals to, we know I is and we know Im. I is to be 25 amps plus 0.00005. That will be the total current here will be 25.0005 amp. Approximately I will be equals to approximately 25 amp. Now we have solved for we know the answer for the first question. Now let's move to the second one, which is calculate the value of shunt to give full scale deflection when the total current is 10 amp and 75 amp. So we solve for the first one, which is 10 amp. Solving for the first one, which is 10 amp, we first write the formula. Since we are looking for the shunt, the RS, or you might write normal is like shunt is equals to IM times RM divided by I total minus IM, knowing that the I that is given there is 10, the total current that is given there is 10. So if you fix in the formula, the first one you have solved for IM and RM, then you look for now fixing this IM, which is 0.0005 times 1000, which was RM here, RM divided by 10, which is the total current minus 0.0005. The answer here will be S will be equals to 0.5 divided by 9.9995. So S or RS will be equals to 0.050 ohms. This is how to solve this particular formula in case you come across it in exams or in test hall. Just know the formula, others are simple. Then solving for when the total current is 75, I is 75 amp, and that will be just fixing there in the formula, which is S is equals to IM times RM divided by I total minus IM. That will be just substitute the values there in there. So have 0.8 is equal to 0.0005 times RM is given there to be 1000 divided by the I total here is 75 amp minus the IM 0.0005. So S here will be equals to 0.5 divided by 74.9995. So S will be equals to 0.00667 ohms. This is the final answer to the question that was given here. But if you want to convert it to milliamps, you can still do it, or microamps, how you want to convert it is okay. But I would like to leave my own this way. In case you see it in exams, or just fixing the formulas and just know the formulas to solve it. And I think I should make a video on how to derive the formula that I'm using to solve this. I'll try and do that. Thanks for watching. And I would like to do another question still under this. Yeah, let's do this one also. How will you use a PMMC instrument which give full scale deflection at 50 milliamp voltage and 50 millivolts and 10 milliamp current as ammeter 0 to 10 amp range, voltmeter 0 to 250 volts range? This PD, please don't forget, this PD means potential difference and it's also the voltage. This PD means potential difference and it's also the voltage. And this PMMC is the permanent magnetic moving coil. permanent magnetic moving coil. Please don't forget. And let's go into the solvings. Let's first I like to write out the parameters that is being given that. So the parameter that is being given here is the full scale voltage, which is 50 millivolts, which I then convert it to normal voltage, which is normal 0.05 volts, and full scale current, which is 10. They gave 10 milliamp, and I then convert it to normal amp, to be 0.01 amp. Now the first question that was given there was ammeter 0 to 10 amp range. So I'll first solve for that, and we can recall very well according to Ohm's law, because in electrical everything is revolving around the Ohm's law. Rm will be equals to V over I, as the resistance will be equals to the resistance will be equals to voltage divided by current, which is normal here. Just they gave the formula, the parameters here to be 0V to be 0.05, and the current here is 0.01. So Rm will be equals to 5 ohms rather, which is the resistance, not current. Remember, the resistance here will be 5 ohms. So the shunt resistance, that was for meter resistance. So the shunt resistance here will be R S, or S. I use S in my last video that I did, or in the last calculation that I did. Here it will be Im times Rm divided by I total minus Im. Using this Rs, our normal S is still the same thing. So moving down here, S equals to Im. Here that is given here is 0.0. Here is the Im. 0.01 times 5, which is the voltage, times 5, which is the resistance rather. Sorry, that's not voltage. 5 ohms is the resistance, not the voltage. And the 10, which is the range, the ammeter range is 10 amp. 0 to 10 amp minus 0.01, which is the Im. So you now solve this. A's will be equals to 0.05 divided by 9.99. So A's here will be equals to 0.005 ohms. That's A's, or R is the shunt resistance. The shunt resistance here will be 0.005, or you write the shunt resistance, or you can use normal shunt. So moving to the second one, full scale current. No, that's not the question. Okay, here voltmeter 0 to 250 volts. Now we are going to solve for that one here. So we are going to solve for the second one, which is the voltmeter 0 to 250 volts range. That's the series resistance is equals to R will be equals to V over I. Anything about electrical is around, it's not too far from Ohm's law. Ohm's law formula. Just know the formula, and every other thing you can just do the calculations. The V here is 250 divided by the current. The current that was given there is 0.01. So 250 divided by 0.01, that will be R will be equals to 25,000 ohms. Yeah, check your calculator. You can confirm it in your calculator. Now the series resistance series will be equals to the series resistance minus the where is it? Yeah, the meter resistance that was given here will give you the total resistance. The series resistance or resistance series is the same. That will be 25,000 minus 5, which will give you 24,999 ohms, approximately 25 kilo ohms. So that's the answer to the question that was given here. So for the first one and the second one, that's the answer to those questions. Then thank you for watching, and I think I should solve another question still under that, but a little bit different. Yeah, let's do another example. This one says a current galvanometer has the following parameter: B 10 times 10 raised to power minus 3 Weber meter squared. That's B. This B means magnetic flux density. This B means magnetic flux density. So the current galvanometer has the following parameter. One of the parameters that it has is the magnetic flux density, which is B, that is given here, and the N here is number of turns. The N here is number of turns, the L is the length, and the D is the distance, and the K is the constant. So it has its own formula, and I will show you while solving. So let me just read it. I just wanted to explain what this means. Don't forget this one. The first one here is the magnetic flux density, and this one number of turns, and this is the length, distance, and this K is the constant. So moving forward, we have the parameters that is given here. The question here says calculate the deflection of the galvanometer when a current of 1 microamp flows through it. So here solution. Given that, so these are the parameters that is being given here. I convert it, like for example this one, this B, I convert it to I remove this minus 3, I convert everything, and this one from millimeter to meter, to meter here, and this is the constants that is given from microamp to raised to power minus 6. Then firstly we have to solve for area of coil. Area is equals to I'll be a little bit fast in this one, times the density. So area times distance rather. So the length times distance, length times area is equal to length times distance. I don't know, this one I'm making mistake here and there. 0.016 times 0.016, that will be area A will be equals to 2.56 times 10 raised to power minus 4 meters squared. Area is in meters squared. You can don't just watch, stay with your calculator. Anything you're doing, just confirm it, try and do it also. When you finish watching the video, go back, try do yourself, solve the question yourself, then come back and check whether you have the answer. And since we have solved the formula, then we look for the deflection. This is the deflection formula. Deflection formula, which is theta will be equals to n, this is n, not micro, n times b times I, which is current, times area, all divided by the constant that was given. So theta here will be n, which is 200. Okay, let me solve it one after the other. The first one, the numerator, let me solve the numerator first. 200 n, which is 200, I'm solving this one first. 200 times 0.01, number of turns, times b is given here to be 0.01, number of turns times b times the area we also solve here to be area is solved here to be 2.56 times 10 raised to power minus 4, and times what else, current. Oh, I supposed to bring current before area, but there's no problem there. Current 1 times 10 raised to power minus 6. So solving that, do your normal calculation. The numerator there will be 5.12 times 10 raised to power minus 10. So bringing it to the formula that was this one, I just solved for this one, this is it. I just solved for this one, which is the answer. So the theta here, theta will be equals to, bringing the formula that I just solved for the numerator, 0.2 times 10 raised to power minus 10, all divided by the constant, which is k. K was given to be 12 times 10 raised to power minus 7. So theta here will be equals to 5.12 all divided by 12 times 10. I'm bringing out these two 10, this times 10 raised to power minus 10, and this one minus 7. So minus 10 plus 7, that will be 3, minus 3. That's what you have there. Then you do normal division here, you have your theta to be equals to 0.12 divided by 12. That will give you 0.427 times 10 raised to power minus 3. Please use your calculator. I used my calculator. Then theta will be equals to 4.27. This is the answer, but I just want to make this to come first. This is the normal, this is the correct answer. If you leave it like this, as far as this one is minus 3, you are correct. But I just want to bring this 4, like add minus 1 to this 2, so that it will be minus 4, and I'll bring this 4 out. That will be times 10 raised to power minus 4. The unity is under radian, just give it rad. So that's the answer to the question that was given here. Thank you for watching. I really appreciate you staying. Always come around. I'll be dropping other videos.